Welcome to video 5 of the tidyr lecture. In this lecture we will start by looking at the names pattern option of Pivot Longer. To start this out, let's start by reading in a data set called Craig. And let's take a look at this data set. So I can see what I would like to do is have the treatment for each person specified and then the value. So what I'd like is to have a column for treatment A and treatment B. But in this case, what's happened is the value of the variable is a part of my column name. So in this case, what I'm going to do is I am going to use Pivot Longer, and I'm going to specify that I want the columns to be the ones that start with the word treatment, and the names are going to go to a new column that I will call treatment. The values will go to a column called result, but I'm going to use names pattern to say it starts with treatment and whatever follows after that is what's going to be my new column name. So now I can see the result is exactly what I wanted. Frequently, we may have multiple variables stored in one column. Let's take a look at the World Health Organization's data set that is built in to tidyr. I can see here all of my variable names, and what are these? See, we have new or new underscore. Most of them look like they're new underscore, but if I go far enough in my list, I can see down here I have just NEW. That's the first, the prefix, and this indicates new or old cases. This data set only contains new cases, so I can basically ignore those areas. The next several letters will describe the type of TB. So REL is for relapse, EP is for extrapulmonary TB, so forth. You can look in the document that I gave you and see exactly what all those cases are. Then I've got either an M or an F standing for male or female, and then what follows after that is the age group. So I have 7 age groups. I have, let's see, I have 0 to 14, I have 15 to 24, 25 to 34, 35 to 44, 45 to 54, 55 to 64, and 65 and older. So we can break these variables up by specifying multiple column names in names 2, and then either providing names underscore sep for separate or names pattern. Here, names pattern is the more natural fit. We're going to be using regular expressions. You give it a regular expression containing a group which is defined by a parenthesis, and it puts each group in a column. Now, we're going to go into regular expressions in another couple of weeks in the class, but for now, let me just show you how you might use this. So, for instance, I could take my WHO data set, Pivot Longer, tell it the columns that I want to specify start with, let's see, what was the first one? New underscore SP underscore M014, and going all the way through this last one. And the names too, I'm going to have diagnosis, which is this second, given by the second part, gender, which is given by this, and then age, which is given by the last bits. And I'm going to give it the pattern that says it's new, maybe or maybe not, followed by an underscore. Then whatever comes next is going to become diagnosis, followed by an underscore. The next one letter is going to become gender, and however many characters are left are going to go into age, and the values will go into count. So looking at the head of that, you see, I now have split those out. We could go one step further and specify the types of the gender and the age. And this is actually a better practice. So the way I will do that is I will give it a names P types for prototypes. So you can see what I have done here. I've done the same exact things as I did before, but I've told it now drop any things that are NA because we don't need those in our list. And then I've said, okay, I'm going to give prototypes for the names. Gender is going to be a factor with the following levels. And age is going to be a factor with these levels, and it is going to be an ordered factor. And so now if I look at who tidy, I've lost those that just had NAs, and now I have an ordered factor variable for age and a factor variable for gender. I'm going to now read in the weather data set that you should be able to have downloaded. And if I look at weather, this is the daily weather data for the Global Historical Climatology Network. This is only from one data station in Mexico for 5 months in 2010.